Okay, welcome all. Today we have the seminar presentation of Duhan Ölmez. Let me introduce him. But firstly, hi Duhan Hocam.
Hello.
Let me introduce you briefly. Duhan Ölmez graduated from Yaşar University, Department of Architecture in 2016. He also completed his master's degree at the same university in 2019. Thesis titled The Role of Virtual Environments in Architectural Design Education, Spatial Perception and Distant Collaboration. He is currently doing his PhD in architecture program at İzmir Institute of Technology. He worked in many architectural and visualization firms during and after his undergraduate period. Currently, he is working in Yaşar University as research assistant. Today, he will share with us his presentation titled The Role of Virtual Environments in Architectural Design Education.
Thank you, Hocam. I guess I can start, right?
Please.
Okay. Hello, everyone. Today we will talk about my master's thesis presentation. The title was Can Virtual Environments Be the Key Towards Increasing Spatial Perception and Distant Collaboration in Architectural Design Studios? I wrote it in 2019 with Onur Hoca, who was with us back in those days. So the content of the whole presentation will follow this order. We will talk about the background of the whole things that I will mention, and then I'll state the problem. I will ask my research questions, and then I will talk about the methodology, and then we will have a discussion and the conclusion. And at the end, I put the results in detail to the ones who are interested in. So, with the background, as a word group, virtual reality includes two clashing definitions. While virtual corresponds to something that is merely conceptual from physical reality, reality design stands for the quality or state of being existent in material. When these two components combined, even if virtual reality is known for perceiving computer-generated graphics nowadays, the meaning corresponds to the process of interpreting imagery data to create a meaningful outcome for individuals in their own heads with their cognitive powers. The recorded idea of virtual reality, introducing a fictional creation or exaggerated real-life stories, have been started with storytelling by cave paintings in ancient era. The Journal of Virtual Environments started with the narratives, continued with the written documents, paintings, photography, motion pictures, video games, and many other interpretations of information that we actually perceive with our sensory abilities. The very first virtual reality device was Blue Box, used for military trainings during World War II, and it generated a virtual environment for pilots to overcome the dangerous situations safely from a distant location in such a complex device. However, the first one to introduce the idea of virtual reality Google was Stanley G. Weinbaum in his book Pygmalion Spectacles. The story was about a glass that makes people see other realities through, just like the headsets that we have right now in our disposal. After the idea, many virtual reality device prototypes have been introduced to both educational and commercial use, and we can see some of them in here. And it actually started with 1962 with that huge device that people are sticking their heads into, and then we had the ones who are mounted on the ceiling that is coming towards a person's head, and then right now we have this little beautiful person. At the end, now we are able to build our own Google Cardboard virtual reality Googles for free and explore virtual realities with our own smartphones. So there are various extents of the use of virtual reality systems, especially in education and training systems. They are highly in use since virtual experiences increase the skills that are required by different professions. So now that the virtual reality part is done, now we will talk a little bit more about architectural education. According to Salama, there are 4 different practices in architecture. They are really simplified versions, of course. The builder, the academic, the engineer, and the scientist. However, the Cambridge Dictionary defines architect as a person whose job is to design new buildings and make certain that they are built correctly. And nowadays, we are also undertaking the process of the whole life cycle of the building if necessary. So to train an architect, there are a lot of discussions going on about how to train one. And architecture education requires various courses related with architectural design, building construction, history of architecture, structures, materials, equipment, professional code, professional practice, art, and even more curriculums are included into designing an architect, training an architect. But there is a consensus about having the design studios as a core element in architectural education, where students were expected to solve an architectural problem with their own creations, which is also known some ill-defined problems. While creation and design challenge play a significant role, 2 key aspects of design studios are spatial perception through architecture representation tools and collaboration between students as well as between students and instructors. The primary goal of architectural discipline is to create 3-dimensional volumes according to given programs, problems, and situations, while considering aesthetics, human behavior, safety, and many other aspects which can affect human life and interactions in those volumes. As architectural creations, volumes are physical environments. Spatial perception is individuals' ability to understand those environments by their senses and interpreting them to create a meaning for themselves. However, during the process, since the design is not built in architectural design education and it's completely virtual, how to understand and explain those spaces plays a huge role, and it is only available with architectural representational tools. So to present the imagery data, the imagery creations to colleagues, instructor or clients, architects are using representation methods such as conceptual sketches, analytical sketches, observational ones, orthographic projections such as plan sections, elevations, details, 3-dimensional perspectives, axonometrics, CAD/CAM models, fly-through videos. Like, there are so many different representation methods that we can use nowadays to, understand, to tell about our projects to the instructors or our colleagues. And now with the advancement of technology, architects are able to explain their projects using innovative technologies such as on-screen virtual environments, immersive virtual reality, or augmented mixed reality systems. And all these representation methods in architectural practice and education offer unique aspects of design and focus on various qualities of the project. Based on which phase the project is, each method has advantages and disadvantages along with the way of using them. To understand the spatial creation of architectural representation methods, questionnaires with Likert scale have been highly used in the literature, and that's what we realized when we were going through the background. And for the distant collaboration, architectural practice and education considered as an extremely cognitive profession which requires certain communicative skills while designing, presenting, or experiencing creative spaces. Since design studios based on imaginary creations, communication between the student and their instructor plays a significant role in the process of design studio. When collaborative platforms in architectural design studios have been investigated, email-based systems, video calls, web blogs, data exchange, CAD and BIM systems have been used extensively in the literature. And all these methods are based on representing 3D creations in either text, 2D drawings, 2D representations of 3D models, basically. However, when it comes to the measuring the architectural collaboration, there is a huge confusion and unclarity about the process. Since it is highly subjective and distinctive, no metric nor a system to measure a collaboration established in a consensus. Yet, open-ended questions have highly been used to investigate the process of collaboration between different parties and during the architectural design process. Most of the studies were based on single-time short-term events. Training the attendees for such special use technology have not been considered in the literature. And even if it's not a rocket science, learning how to work with virtual environments, design through them, present the works, and collaborate within them requires a steep learning curve because there are so many devices and so many various controls are included. So hand gestures, unfamiliarity in virtual environments to communicate and modeling virtually, limitation of creation methods in immersive virtual environments are also causing problems in the literature. The confusion of the word virtual reality, the use of walkthrough videos, CAD drawings, BIM models, 3D digital models, etc., instead of immersive virtual environments to experience the design is also something seen in the literature, because back in the days, looking at a digital model was considered as a virtual reality, which nowadays it's just looking at screen basically. Another problem was manually redesign and remodel projects in certain way to showcase in virtual reality, and data exchange problems between CAD BIM to immersive virtual reality. So basically, if you want for people to look at your models in virtual environments, you need to have a coding background, like you need to go into a game engine and create a software that is making the other person able to see what you created, and this background most of the time isn't realistic for architectural design studios. Another problem was the use of numerous platforms together to provide collaborative design process between parties, creating coordination problems among all these softwares. And financially not feasible setup with high-end computer systems, expensive VR equipment, scheduling problems with insufficient equipment amount is also another problem that we see in the literature. So now we come to the research question. After all these problem statements, two main research questions are as follows. The study was designed to measure the spatial perception in different virtual environment setups and distant collaboration for architectural feedback sessions through 3D digital models. So how digital architectural representation methods influence architects' perception of space, and how can distant collaboration between architects and in virtual environments affect the project development process. So for the methodology, what I have done is I created a course in Yaşar University in 2018 and 2019 fall semester named Virtual Environments in Architecture. So basically, the course was established to give the students the idea of how 3D models are working and to see this process of how the collaboration in those environments are happening. Since the research team had no interventions in enrollment of the students to the offered elective course, the randomness of the sample is ensured just by creating the course itself. So the aim of the course is to provide students insights on how to use virtual environments effectively during their design phase, communication for their projects, and presenting their final works. No specific modeling software is introduced in the course. Therefore, students were free to use any software they would like to use to create their own 3D digital models. And these are some slides that we showed the students about the infrastructure, how it's happening, what is the design process, what are NURBS, polygons, and etc. After showing the essentials about 3D digital modeling and virtual reality systems, students were subjected to a previously designed experiment throughout the semester. Like we created sets of experiments for the whole semester, and during this phase, like 14 weeks, students were answering specific questions. Digital tools have been used extensively to collect raw data and measurements. Throughout the experiments, the communication with students were provided by using the lecture system that we have back in the days in Yaşar University. And for collecting data from surveys and questionnaires, Google Forms developed by Google have been used. And what is more important in this thesis is that for exchanging data and providing a common ground between different 3D digital modeling applications, another software called Kepler VR was proposed and presented to students, where they were able to observe the 3D digital models in on-screen virtual environments and immersive virtual reality views, as well as leave reviews in the virtual environments as comments on the surfaces. And we also developed this software to let students use it during the whole semester. So for the sample, in total, 46 students enrolled in the course, while 22 students worked individually for their design studios. There were 5 different 2-member group works, and there were 3 different 3-member group works, and also 5 students had no design studio class in the same semester. Therefore, they assigned to be reviewers, which means they did not develop any model. However, these reviewers reviewed more projects than the others and fill in the forms even more times. So for different experiments, projects, tags, and personal tags of each individual has been used to indicate which students is going to evaluate whose project. This procedure handled randomly, therefore every week students were expected to observe and evaluate different projects. So basically we created a procedural random method, so no one actually interviewing with another one during the semester, so the whole process was completely random. So for the questionnaires, as mentioned before, to the best of our investigation, there is no consensus on methods in measuring spatial perception. By other words, no standard technique or design of experiments has been agreed as standard in the literature. And previous works have adopted numerous different approaches in their research design, and the same issue manifests itself in measuring the role of collaboration. And each experiment consists of numerous questionnaire surveys where the numerical responses were either in nominal or in ordinal Likert scale. The questionnaires also contains open-ended inquiries to collect qualitative data, which reveals the crucial information that cannot be covered with numerical data. Questionnaires have been used throughout the semester in different experiments. These questionnaires were mostly used Likert scale. However, qualitative open-ended checkbox questions also have been used. And questions related with understanding corresponds to perception, while the ones with suggesting and figuring out were for collaboration. And this is basically the backbone of how we created the whole questionnaires in the system. And for the experiments, throughout the semester, we had 4 different experiments. The first 3 of them were just 1 day experiments, basically. And the 4th experiment was for the whole from 8th week to 13th week to the final. So it was a process of collaboration for students for their own projects. So the first experiment was to the first encounter with virtual environments for the students, and we understood their demographic, and we created those tags and everything. And experiment 2 was for comparing presentation methods and spatial perception in digital orthographic drawings and on-screen virtual environments, immersive virtual environments. And the experiment 3 was more related with the panels, the videos, and everything. And then we have the 4th one, which we will discuss in detail. So for the first experiment, it aimed to establish a validation process about students' skills in virtual environments to create the 3D digital model, write descriptions to explain them, share it with classmates, and evaluate their models. After the qualification of the students are recognized, they continued with the rest of the experiments, basically. The second experiment aimed to measure spatial perception of 3 single-family houses in different virtual environments presentation setups. And projects were chosen from an actual commercial projects developed by the same architect, which is me, and digital orthographic drawings, which we call DOD, and on-screen virtual environments, OSVE, and immersive virtual reality, IVR, we introduced to the students in this comparison. Since 3 different projects were choosing, all the students looked at these projects in different groups and presentation methods. Later, their spatial perception and what kind of architectural features they understood the most in different setups have been measured with the questionnaires. So this experiment setup actually allowed us to have the most suitable one, because everything was random among the view type and the project and who's going to look at which project. So the third experiment was also like the second one. However, instead of using small commercial projects, students observed third-year design studio projects. Besides, their spatial perceptions were measured with the digital representation boards and digital walkthrough videos against on-screen virtual environments views and immersive virtual reality views. So we grouped these two representation methods together, and students basically said which one was better for what kind of understanding for the whole process. And again, students looked at different projects in different representation methods, and their perception of these spaces have been measured with related questionnaires. For the fourth experiment, which was again a whole process, the latest experiment designed as a process of multiple tasks in continuous weeks to respond why architects should use virtual environments during their architectural project development in design studios for communication through the design itself and between themselves. Primary aim was to handle this process from distance, which means students did not attend the course physically. So before the pandemic, actually we tested the virtual studios, the distant collaboration, not coming to the universities. Along with the course and students' design studios, volumetric mass models and planar models techniques were expected from them first. And later they were expected to create the vertical surfaces on their planar models and develop their spaces. And then placeholders and furnishing in the spaces added on the students. And they were asked to choose the most important area of their project. And after all, a partial digital model of their volumes have been asked from students. The very last experiment of the current study aimed to create a collaborative environment for students. Since students made reviews on each other's projects and spaces throughout the semester using Kepler VR, they were able to see the comments and answer them and continue the process of feedback. Therefore, experiment 4.4 focused on these reviews and their communication through them and the efficiency of giving and receiving reviews in virtual environments. For the data analysis, descriptive statistics of the experiments indicated in the quantitative results of the questionnaires and their impacts for the study basically aimed. And after demonstration of each answer set of questionnaires, discussions handled by the help of visualization of the data. Even if both quantitative and qualitative data collected from the students related with the experiments, only quantitative data examined widely to generate the outcomes, whereas qualitative answers were used to have a deeper understanding of the whole topic. So for the presentation methods interrelations, as we said, we have all these 5 groups. The first one is the digital orthographic drawings, the most traditional method that we have. And the second one is the on-screen virtual environment, which is basically what we do most of the time while we are designing the project, like we are looking at the screen. The third one is the immersive virtual reality, which is like a headset is on and you are able to navigate within the space itself. The third group includes the digital presentation board, like design presentation boards, like the posters that we prepare, and digital walkthrough videos. The last one is a combination of on-screen virtual environment and immersive virtual reality. So from now on, we are looking at the results. So what this is basically on the Likert scale, the -2 and -1 corresponds to the negative answers. 0 is the neutral one, or like, I don't want to answer that. And 1 and 2 are basically the participant agreeing with the system. So understanding of the plan organization of the project, basically the immersive virtual reality, let me show you like this. Yeah, immersive virtual reality. So the 0 point is here. Basically, students said immersive virtual reality is not the best option to understand the plan organization of the project. However, the digital orthographic drawings and digital presentation boards with the walkthrough videos are the best solution to look at the plan organization. For the human scale of the building, students said that all the traditional methods were not very useful. However, the combination of on-screen virtual environment and the immersive virtual reality systems, giving the best feeling to understand the human scale and the building size. Understanding of the rooms and their relations is the same with the use of both systems together. So individually on-screen virtual environments and immersive virtual reality, students didn't actually go on with that for the understanding, but the combination of these two representation methods, they got the most out of the rooms and their relations. And also digital orthographic drawings probably also created the best idea for the relations of the whole spaces. Understanding of the circulations, again, students, that there were no neutral answers, so most of them were positive. So again, on-screen virtual environments and immersive virtual reality was the best option for that for the students. It's the same with interior and exterior relations. And understanding of vertical elements, also the digital presentation boards and digital walkthrough videos seemed to be useful in this sense as well. And understanding of the openings and their impacts for the interior, there were no negative answers for on-screen virtual environments and immersive virtual reality. So basically, when they entered the space in those immersive environments, students said the best option to understand the impacts of those openings is the technological methods which we have in their headsets and on their screen. And digital orthographic drawings, even if they include the sections and the elevations, students said, like, we don't prefer using this one. Understanding the solid and void relations on the facade, again, the same situation with the previous one. Understanding the interior and furniture organization, digital presentation boards and walkthrough videos were the least liked one. And on-screen virtual environment and immersive virtual reality was, again, the best option for that. And understanding the vertical relations of horizontal surfaces, the same happened. However, the on-screen virtual environments, like not within the headset, but just looking at the screen and navigating through the 3D model, was the most suitable one for the students to understand the vertical relations of the horizontal surfaces. Understanding of the volume and how it feels like to be there is basically selected the best with the on-screen virtual environment and immersive virtual reality again. And in digital orthographic drawings, actually, this is the highest that we see the negative answers from students, because they are not in that professional expertise in their education to understand how it feels like to be inside the spaces just by looking at the digital orthographic drawings. Figuring out the overall problems with the project, again, orthographic drawing, presentation boards, on-screen virtual and virtual reality systems, they all failed to a point. However, the use of screen and the VR headsets provided the best option for them. Figuring out the problems with narrow areas and small volumes are the same. Both use of on-screen and immersive virtual reality provided the best answer. The problem with the furniture placement, even if not almost all students like, this is the most negative aspects of all these systems. However, basically the traditional methods, these two little fellas over here, they basically selected the least likely ones for problems with the furniture placement. Suggesting a new layout for the overall room organization. Here we go through the collaboration part. And in this sense, on-screen virtual environment provided the most suitable version. And suggesting a new circulation for the project, I was surprised when I first looked at this answer, because I was expecting digital orthographic drawings to come to the forward for this one. However, even if there is no consensus among the students, the use of the screen and the VR headsets provided the best environment for them again. Suggesting a new solution for the interior furniture placement, again, there is no significant change between the answers. However, the on-screen virtual environments got the most positive attitude. So, for the process evaluation, students have been asked open-ended questions along with the questionnaires they took for all the process, that is qualitative data collected to establish an understanding related with distant collaboration. After investigation on qualitative data collected from students, most of them found the idea of giving digital reviews in virtual environments with 3D digital models for distant collaboration is useful for project development. While for distant collaboration in virtual environments to be easy, fast, direct, and useful for all the students, they also indicated not conducting the project owners in person, but communication through a platform, being able to see spaces themselves in an immersive setup, the process of teaching virtual environments, fulfilling the needs of the new generation of students about technology, including the design studio professors and the students, would be beneficial for distant collaboration in the environments. So for further observations on students' comments about the reviews, they received pointed out what they received actually pointed out that most of them found the idea of getting critiques from many people useful for development of their projects, and also the quality of the reviews and the topics within them is a concerning issue for the students. However, the constructive reviews generated good impact on the design studio process, as a student mentioned. So, for the conclusion, as I said, these two were our research questions. And so the results obtained from the current study, like back in those days, demonstrated that digital orthographic drawings as a conventional method for showcasing the design ideas are useful to understand the overall project layout and the relations between volumes, as we have right now. Yeah, I guess you can hear me again, right? So on one hand, almost all students felt comfortable with seeing the evaluating the project on screen virtual environment view. However, most significant advantage of this method seemed to be understanding the interior, exterior space connections, and vertical relations of horizontal surfaces. On the other hand, immersive virtual reality views was significantly useful to figure out problems related with narrow areas and small volumes, and additionally to understand the human scale and the size of structure openings on the surfaces and their impacts for interior areas, interior design, and furniture organizations, immersive virtual reality was a viable tool for students. Based on the results, one can suggest that students understand and evaluate the designed volumes themselves more efficiently in on-screen virtual environments, like looking at the screen, and immersive virtual reality with the headsets views, compared to digital orthographic drawings. And both in digital presentation boards and digital walkthrough videos and digital orthographic drawings, understanding the quantitative features about the project, such as the dimensions, square meters, axial heights, etc., and the organization of the space have been more efficient for the students. And outcomes of the experiments demonstrated that the students significantly preferred explorable 3D digital models over the presentation boards and walkthrough videos to understand various extents of the projects by themselves. And in parallel, on-screen virtual environments and immersive virtual reality views were found to possess a high impact on understanding the idea about the project and how would it like to be inside that volume. At the beginning of these experiments, almost all students indicated that CAD and or BIM models with the provided descriptions were enough for other collaborators to evaluate their projects. Further investigations through the last experiment showed that students found virtual reviewing systems were significantly beneficial towards their development of their projects. And our results suggest providing feedback while indicating problems related with the topic, with the project and the models with them, and communicating through reviews in virtual environments were highly useful. Another major outcome was the level of consensus have been reached on usefulness of receiving reviews through virtual environments. And to students, these reviews were constructive, and they basically help the development of their project, even if they are receiving these feeling related reviews from their friends within these environments. So, to conclusion, for the further research, it is urgently required on this state-of-the-art technique and its imminent effects on how we deliver our education using this technology, there needs to be a technique and a standardized way, basically. And we recommend the sample in future studies shall be extended to the instructors of the design studios as well as the professionals in the practice. Since architecture education is not handled within the same methods in every university, because Yaşar University, we know that we highly use technological ways anyways, like students are really used to this idea. Applying the same experiments in other universities with a different sample may result differently. It's either positive or negative. We also faced significant challenges in methodological aspects through conducting the current study. To overcome, we strongly argue that standard measurement techniques on spatial perception and collaboration must be proposed. And basically, this is all. And it's just 35 minutes.
Okay, thank you, Duhan Hocam, for your presentation.